Okay, Assalamualaikum warahmatullahi wabarakatuh. So we start again chapter number 8, uh, part number 3. Okay, so we continue with this vision biophysics. So how we can see or how the signal or how the image is turned into signal and sent to our brain for the processing. Okay, so here these are the structure of human eye. Okay, so the eye and the light enter here, focus to this part, then from this image it convert to a signal sent by this vein to our brain for uh, interpretation. Okay, so this also again the structure of human eye. So you can see that the ray tracing. So these are the image and these are the image. So this image uh, turn into signal, then sent to the brain. Okay. So how I work? So light enter the eye through a transparent membrane called the cornea, a membrane that covers a clear liquid region known as the aqueous humor, behind which is a diaphragm called the iris, the colored part of the eye. The iris adjusts automatically to control the amount of light entering the eye. The opening in the iris through which light passes is black because no light is reflected back out from the interior of the eye. The lens is a clear, flexible cellular structure. Okay. Behind the lens is a region filled with jelly-like substance called the vitreous. Okay, continue. So the retina is complex array of cell rod called rod and cone that act to change light energy into electrical signal that then pass through along the optic nerve to the brain. So the region of the retina where the optic nerve enter contain no photoreceptor and constitute a blind spot on the eye. That one. And at the center of the retina is a small area called the fovea, about 0.2 millimeter in diameter, where the cones were very close packed and the sharpest image and best color discrimination are okay. So if the color or the light hit this cone, then we can have more color. Okay, so these are the optical constant. So the Helmholtz uh, schematic for the relaxed eye. Okay, so here distance from front surface to of cornea to front of lens 3.6 millimeter, lens thickness 3.6 millimeter, radial curvature cornea 8.0 millimeter, front of lens 10.0 millimeter, and back of lens 6.0 millimeter. Okay, so here we can get this radius, this radius, and this radius. Good. This one when the eye is relaxed eye. Okay, and the refraction index of the eye component. Okay, so when the light enter the surface, the membrane, so it will be reflected. So the reflecting index cornea 1.38, aqueous humor 1.33, lens 1.41, vitreous humor 1.34, air 1.0, water 1.33. Okay, so we need to add that, meaning that the ray will be reflected again and again and again by this material. Okay, our eye only can see the color from the range 380 to 700 nanometer. That is from blue to red. Okay, so the cornea absorbs most of the energy for the eye equal to 300 meter. Okay, so greater than that it will damage the cone and the rod. Okay. So the response of the eye depend on strongly on light intensity. So high intensity of light. So our iris will be smaller. Okay, and low intensity of light, our iris will open wider. Okay, so if a person remain in bright surrounding, the process is called photopic vision and involve light attenuation. And in dark surrounding, eyesight is dark and the process is called the scotopic vision. Okay, so this is one. Changing light intensity of surroundings require a period of irradiation during which a person is temporarily blinded. Okay, so daripada gua kita masuk keluar ke luar. Okay, so we need some time to adapt. Okay, so these are optical properties. So from our physics with WBO, with wave and optics. Okay, so these are optics. So these are the ray tracing. Okay, so these are the image. Okay, so we can get this object and these are the image. Okay. Okay, so the power of lens P equal to P over 1F, the focal point equal to 1 DO plus 1 DI, the lens, outer radius, and the inner radius. Okay, when the eye is fully relaxed, P infinity equal to 1 over DI. Okay, this is image, the distance of. Okay, so when eye is fully accommodated and the object is at near point, so we have this from our physics with vibration and VWO, vibration wave and optics. So we have the power is equal to 4 diode. Okay. So optical properties. So the power of accumulation is defined as the difference of the power associated with the extreme of vision. For a normal eye, it is 4 diopter. Visual acuity is defined as the minimum angular separation of two equidistant points of light that can be resolved into two separate objects by the eye. The defined are closer, the eye sees light coming from a single point source. Okay, so you cannot differentiate from where the light is coming. The acuity of photopic vision, low intensity light, is highest about 20 degrees from the fovea, a line through the center of the lens and the fovea, where the intensity of rod is greatest. So for photopic vision, acuity is highest on the fovea where cones are most dense. Okay, so photopic vision is always greater than photopic vision. Okay, so these are how the light absorb goes to. So the retina, optic nerve, okay, blind spot. These are the blind spot. Light coming to the axon and ganglion cell. Okay, so here we have the rod cell and bone cell. Okay, so this one will determine from this energy. So we define to send the which signal to our brain. Okay, so here the photoreceptor. Okay, the outer segment of this. So we have this photoreceptor, and here we have a protein or a molecule for the retinal cyst or the rhodopsin. This, okay. So this will uh, this one will change the conformation depending on the energy of the light. Okay, so then we can send a signal to our brain. Okay, so these are the color of certain pigment disappear under sustained exposure to light. So these are the bleaching. Okay, so if we put macam kita letak apa kertas berwarna dekat luar selepas berhari-hari, so kita akan dapat uh, warna tu makin pudar. Okay, so the retina contains two types of light sensitive cell called photoreceptor PR cell. The eye contains of 6 to 7 million cone and about 120 million rod. Okay, 7 million cone for high intensity light and 120 million rod for low intensity light. So the PR cells are located inside a matrix of pigment cells that act as non-reflecting background and about 10 to minus 6 meter in diameter. After light absorption, PR cells send out an electric signal to our brain. Okay, so here we see what are the cone and what are the rod. So the cone have a relatively high threshold of light intensity before they are triggered. Okay, so here you can see that even if we have a very high intensity of light, so we need again higher light intensity other than this threshold, so that the cone will act on that light. Okay, on firing they send a signal to the brain and the signal for the color vision. Okay, so cone is for the color vision. Next is the rod, responsible for low intensity black and white vision, in other words for nighttime viewing, and have a very low firing threshold. Okay, so it's very sensitive. Okay, so the protein that change the energy of light into the signal is the rhodopsin, okay, or the visual purple. So these are the light absorbing protein. So it will absorb light, locate in the rod, strongly absorb visible light in certain rows or for purple frequency range, and it arranged in planar structure anchored in a membrane that can transmit electrical signal and respond to stimuli received from the molecule. Okay, so here we can see that these are the cis form, one state, A state, to B, we can become B state when we get the light. Okay, transform from this A state to B. Okay, so the light active group is called 11 cis retina. After retina absorb a quantum of light, it isomerizes. So we come from this type to become this type. Okay, or cis state. The new structure is called 11 trans retinal, a straightened out version of cis retinal. The isolation takes place in about 10 to minus 2 seconds. Okay, so very short time. The energy of the light quantum is transferred into restructuring of the molecule. Okay, and the acceleration blocks the excited molecule from falling back into its ground state and emitting the light quantum. Okay, so rhodopsin is not a fluorescent molecule. So okay, so meaning that we are not going to see a fluorescence after the absorption of light. Isolation alters the chain of the trans part of the rhodopsin protein, and it starts a chemical reaction and produce electrical activity by closing ion channel in the membrane. And the origin of the electric signal then usually reach the brain as a passage of black and white vision. Okay, so from this light changing the conformation of this rhodopsin and from that you can produce the electrical signal and send to the brain, and we get the vision. Okay, and these are the color vision, visible light from 380 to 700 or 800. Okay, again, this for the color vision. So we have the rod and cone. So rod are for the color vision and cone for the black and white. Uh, so rod are found throughout the retina except for small region. No, the rod are for black and white and cone are for color. Found throughout, so rod are found throughout the retina except for a small region in the center of the fovea. More sensitive than cone and are responsible for vision, and vision is very dark environment. So do not yield color information. Okay, so just producing the image. The cone concentrated in the fovea and are associated with color vision. Three type of cone is sensitive to a different range of effect. Okay, so here we can see that for the cone we have three type of cone. Okay, so these are the three type of the cone. So depend on the three color pigment, red, green and blue. So if we are color blind, so we are meaning that we are missing one of the pigment. Only if the light intensity is great enough would color sensation be present. Okay, so the threshold of the activation or the energy of activation is high. Okay, so how is the reception of our eye? So alpha mean equal to 1.22 lambda over A. These are the Snell law. Okay. So alpha mean the minimum angular separation of gradient. Lambda is the wavelength of light in the medium. A is the diameter of the aperture, the minimum diameter of about 2 millimeter. So when n equal to refractive index is equal to 1.33, alpha mean equal to 2.3 times 10 to the power minus 4 radian. Okay, so very strong stepper, not very strong separation. Okay. Two active cone must be separated by an inactive cone to create the sensation of a image. Okay. Okay. The eye cannot detect detail that create an image smaller than the spacing of the light sensitive cell. Okay, so maknanya kalau kita ada detector, kalau kita ada dua detector, kita uh, tujukan laser antara dua detector tu. So dua-dua detector tu tak menangkap laser tersebut, jadi dia tak akan dapat apa-apa bacaan atau signal. Okay, outside the fovea, light sensitive cells are not as closely spaced and visual acuity is considerably less by a factor of 10. The both dots are image of small light source and fall on adjacent cell. They are interpreted as a single larger dot. Okay, so here we cannot the resolution. Okay, so even though these are two light source, but we can only see as a single large dot. Okay, so the refraction limit. Okay, so uh, the light refract when entering each uh, refracting index. Okay, so a point source of light will not make a point image on the retina. It will produce a spot about 2 micrometer in diameter, very nearly the size of the retinal cell. Okay, so if we put all the light will cover the whole or cone or the whole rod. Okay, so if we kalau kita ada uh, piring besar, semua uh, semua cahaya akan menerangi semua bahagian dalam piring tersebut. Okay, so that this is it. Okay, so I think we can stop here for the vision biophysics.